Hello and welcome to the course Design Borefields with Confidence. This is the 7th part of this course and we will be talking about how you can design a borefield with GHGTool and more specifically the methods implemented in GHGTool that can help you to determine your required borehole depth or your required borehole depth and required number of boreholes. But before we jump into what we will be covering in this part, let us recap what we've been doing in part 6. Now, part 6 was all about innovative solutions in the geothermal space. And we mentioned 3 different commercial products that either had benefits related to heat transfer and enhanced turbulence on the one hand, but also on the other hand, a lower pressure drop. Now, in the first chapter of the last part, we introduced the concept of the turbo collector from Movitech. This was a circular probe, a smooth pipe, but now with internal fins installed that rotate clockwise and counterclockwise. And by doing so, it enhances the turbulence at a lower flow rate. So instead of transitioning to a turbulent flow or transitional flow at around a Reynolds number of 2300, this now happened at a Reynolds number between 1700 and 1800. So it enhances the turbulence at a lower flow rate. In chapter 2, we introduced the Movie Ellipse from also the same Swedish company Movitech, which is a little bit the younger cousin, let's say, of this turbo collector. It is a probe with the same internal fins, but now it's no longer circular, but elliptical. And this has another benefit, namely that it can be installed in a smaller diameter due to the geometric shape of an ellipse being more advantageous to fit in a smaller diameter than a classical circular probe. Lastly, we also introduced the Gerotherm Vario and Flux probe from the Swiss company HK Gerodur. Now these are, again, traditional smooth circular probes, but they have a varying wall thickness. Because they said, well, in these deep boreholes, you typically have a very high pressure rating needed in order to withstand the hydraulic pressure inside of your probe. But you only need this pressure rating at the bottom of your borehole, where the hydraulic pressure is the highest. So what they did is they created a probe with a variable wall thickness, which means that on average you have a larger internal diameter and hence also a lower pressure drop. So the Gerotherm Vario and Flux probes were specifically designed to have lower pressure drops with also a slight thermal benefit due to the fact that you have on average a smaller wall thickness. So that was what we covered last part. In this part, part 7, we will be talking about designing borefields in GHGTool. And first we will revisit once again the temperature profiles in GHGTool, but now talking about what fluid temperature we are actually working with. Because historically, the average fluid temperature has been the most common, but you can also design borefields talking about the inlet or the outlet fluid temperature. So this is what the first chapter will be all about. In the second chapter, we will be looking at the methodology to calculate the required borehole depth, where you can say, for example, you have a project, let's drill 10 holes, but how deep should they be in order to make sure that your entire building demand can be fulfilled while still being within your temperature limits. And in the second part, we will also talk about the gradient error, which is rather common when you're working with this methodology. In the third chapter, we will be introducing a method to size both the required depth, but also the required configuration, the total number of boreholes, based on either the minimum number of boreholes or the minimum total borehole length. And the fourth chapter, the last chapter of this part, is a little bit an outlier, let's say. We will be talking about the thermal response tests and how you can analyze them in GHGTool. Because, well, you can talk about sizing methods and calculating the required borehole depth, but everything starts with having good geological information on your location, having the right undisturbed ground temperature and ground thermal conductivity. And that's where thermal response tests can be really, really valuable. So that's why we will end this part talking about thermal response tests and how you can interpret them. So with this being said, let us get started with the first chapter and talk about average inlet and outlet temperatures.